In this video, we're going to look at linear inequalities in one variable. So the first thing I want to do is compare and contrast an equation versus an inequality. So you can see on the left I have x equals 2. That's an equation. Okay, and then on the right I have x is greater than 2. This is an inequality. So an equation, if it says x equals 2, that means I have one answer. So if I label these, let's say 0, 1, 2, 3. If I wanted to map or graph this solution on a number line, my solution would just be 2. So I have one solution. On an inequality though, this is saying x is greater than 2. So again, if I draw some or label some points on the number line, x is bigger than 2. Anything bigger than 2 would be an answer. So 3 would be an answer, 4 would be an answer, 5 would be an answer. But also, don't forget that you have numbers between those, whole numbers. So for example, 3.5 would be an answer, 4.5, 3 1/10, 3 1/100, etc. So all the numbers that are greater than 2. That includes all decimals, fractions, etc. So there's no way you can list all of your answers. So you have to have another way to represent your solution set. So this is where we're going to use interval notation. So when you have an equation, you have maybe one solution or maybe two solutions. I think so far in this class we've only seen one solution, but it's possible to have infinitely many solutions. In that case, you have to have a way to represent all of your answers. So if it's greater than 2, can 2 itself be a solution? So is 2 greater than 2? And the answer is no. So 2 is not a solution. It's the boundary of your solutions versus your non-solutions. So 2 acts as a boundary. And maybe you remember seeing an open circle. An open circle indicates that the boundary is not part of the solution set. So that boundary is not part of the solution set. Remember that you also have an inequality that includes the equal to sign. So you could have a greater than or equal to. In that case, use a closed circle, and that indicates that the boundary is part of the solution set. So that's not the case that we have here. What's in black is the case that we have here. Since we don't have an or equal to sign, that means that 2 is not part of the solution set. But everything larger than 2 is. So everything larger than 2 is to the right on the number line. So that would be our graph. We would put an open circle on 2, and then we would shade everything to the right on the number line. Alternatively, instead of using an open or closed circle, let me give you another option. You could use parentheses or brackets. So parentheses go with the open circle, and brackets go with the closed circle. So instead of having an open circle, you could put a parentheses and then shade to the right. So the parentheses mean the same thing as the open circle. It means that 2 is not included in the solution set, but everything beyond that to the right is. The way you would represent that in interval notation is always the leftmost value, comma, the rightmost value. So it's always the least to greatest. So if you look on your graph, you can see the smallest value that we have, or the boundary, is 2. Since 2 is not included, we would put parentheses 2, comma. The rightmost value, Well, it goes on forever in the right direction. So that's a positive infinity. So your solution set is 2 to infinity using interval notation. So let's look at some examples. So for these, we're going to solve the inequality, then we're going to graph the solution set on the number line, and then finally we'll write the solution set in interval notation. So the first thing we want to do is isolate the x. So to undo this x divided by 8, we would multiply both sides by 8, and that would give us x is less than 16. So we have the x by itself, so that's the solving part. We're now going to draw the number line. I don't bother to write all the numbers. I just write my boundary point and then go from there. So 16 is my boundary. That separates my solutions from my non-solutions on the number line. It says x is less than 16. So that means I'm going to be shading to the left. And since it's less than and it doesn't have an or equal to sign, I'm going to be using a parentheses or an open circle. So you can use either one. The interval notation, remember it's always left to right. So the leftmost value. Notice that I've shaded to the left and it keeps going. So that is to infinity, but since it's to the left, it's a negative infinity. So it starts at negative infinity and it goes to 16. 16 is not included in the answer or the solution set, so I use parentheses. Notice that the negative infinity gets a parentheses as well. That's because you can never actually reach infinity or negative infinity. So it always gets a parentheses. Number 2, to isolate the x, I'm going to subtract 3 from both sides. So that'll give me x is less than or equal to 2. X is by itself, so now I can graph. So I'm going to put my boundary point on the line. I'm going to shade. Since it's a less than, I'm going to shade to the left. And since it has an or equal to sign this time, I'm going to use a square bracket, or you could use a closed circle. So either one. So if you wanted to use a closed circle, you would just do this. If you want to use the square bracket, it would look like this. So again, I have to use interval notation. So the leftmost value, it keeps going forever, so that'd be negative infinity. And the rightmost value is 2, and that number is included in the solution set, so the 2 would get a bracket. All right, number 3. I've got negative 5x is less than or equal to 15. When you're solving this, there is kind of a trick here. So let me just do a quick example. If I have 1, or let's say I have negative 1 and 5. Hopefully you would agree that negative 1 is less than 5. So this is a true statement. We should be able to add the same thing to both sides and keep it a true statement. For example, if I wanted to add 1 to both sides, I would get 0 is less than 6. And we would agree that that is still a true statement. So that means we can add the same number to both sides and keep it a true statement. Let's see what happens if we wanted to multiply both sides by a negative. So let's say I multiplied this by a negative 1 and this by a negative 1. I would get negative 1 times negative 1 is positive, is less than 5 times negative 1 is negative 5. Notice that a positive 1, it says, is less than negative 5. Well, that's no longer a true statement. That's false. So if we want to multiply both sides by a negative, we have to flip this to make it remain a true statement. So multiplying by a negative inverts the relationship. So instead of the left side being less than, now the right side is less than. So whenever you multiply by a negative, you have to flip the inequality symbol. This is also true for dividing by a negative. So when you multiply or divide by a negative, flip the inequality symbol in order to keep your statement true. So in this case, I have a negative 5x. To undo that, I want to divide both sides by a negative 5. And since I am dividing by a negative, I'm going to flip my symbol. So instead of having less than or equal to, I'm going to have now a greater than or equal to. 15 divided by negative 5 is negative 3. So x is greater than or equal to negative 3. I've isolated x, so I'm going to draw my number line and put my boundary point on it. It says greater than. That means I'm going to shade to the right. And since it says greater than or equal to, I'm going to have a closed circle or a square bracket. For my interval notation, it's the leftmost value to the rightmost value. My shading starts at negative 3, and negative 3 is included in the solution set, and it goes forever in the right direction, so that's positive infinity. And remember, infinity always gets a parentheses. Number 4, we first want to start by getting our x's together on the same side. So I'm going to subtract 7x from both sides, and that will give me 6x is less than negative 29. 29 is not evenly divisible by 6. I still need to divide it by 6, but it won't give me a whole number or an integer. So I'll have x is less than negative 29 over 6. So I'm just going to have a fraction. That doesn't reduce, so that is going to be my boundary, and I'm just going to put that number right here, right on the number line, because I get to draw my own number line. If you're having to place this number on a number line that already has numbers on it, or integers, you're going to want to divide those numbers and get a decimal so you know where to put it. So this is approximately negative 4.83. That means it's going to be between negative 4 and negative 5. So you'd have to put your dot somewhere between there, kind of close to the negative 5. But for our case, we get to make our own. So we just put it on the number line. So since it's a less than, we're going to shade to the left. Since there's no or equal to, it's going to be an open circle or a parentheses. So to write our interval notation, it's shaded to the left forever, so that would be parentheses, negative infinity, and it stops to the right at negative 29 over 6. And again, that is not included in this solution set, so we get a parentheses there as well. Number 5, we're going to start by collecting our x's on the left, so I'm going to add 8x to both sides. That will zero out the x's on the right. And I also have to move the constants to the right. So I'm going to subtract 8 from both sides. So negative 3x plus 8x is 5x. Is greater than or equal to negative 10 minus 8 is negative 18. Now I need to divide both sides by 5. So I get x is greater than or equal to negative 18/5. Notice I did not flip the inequality this time. That's because I divided by a positive 5. So it doesn't matter if the 18 is negative. I didn't divide by that. So I do not flip my inequality this time. 18 over 5 will not reduce. So that's it. I'm going to put my boundary point on the number line. It says greater than, so that's going to be to the right. And since it says greater than or equal to, I'm going to put a square bracket, or I could use a closed circle. This means my interval notation, the leftmost value, or where it starts, is negative 18/5 with a square bracket, and it goes forever to the right. So I have negative 18/5 to infinity. Number 6. So we're going to start by distributing the 5. So we'll have 9x plus 5x plus 15 is less than 4x minus 35. We can combine like terms, so we have 9x plus 5x. So that will give us 14x plus 15 is less than 4x minus 35. We will move the x's to the left. So I will subtract 4x from both sides and move the constants to the right. So I will subtract 15 from both sides. So I will get 10x is less than, I believe that's 50, negative 50. Divide by 10. So x is less than negative 5. So here we have our number line with our boundary point of negative 5. It says it's less than that, so we're going to shade to the left. And since it doesn't say or equal to, we're going to have a parentheses. So our interval notation is parentheses negative infinity, comma, negative 5 parentheses. All right, number 7. So we're going to distribute the negative 12 on the left, and we're going to distribute the 9 on the right. This will give us 6x minus 36 plus 12x is less than or equal to 9x minus 36 plus 9x. So we have some like terms to combine on the left, 6x and 12x. So that will get us 18x minus 36. And then on the right-hand side, we have a 9x and a 9x. So that will give us 18x minus 36. So at this time, we want to bring our x's to the left. And look at what happens. All of the x values cancel out. So we're left with negative 36 is less than or equal to negative 36. So we want to say or evaluate, is this true or not? This is a true statement because negative 36 is equal to negative 36. So this or equal to symbol makes this a true statement. So because it's a true statement, your solution set is all real numbers. So if I was going to draw the number line for this, there's no boundary point, and it's just everything. It's the entire number line. All of it is a solution. And if I wanted to use interval notation to denote that, I would say it starts at negative infinity and it goes to positive infinity. All right, number 8. So we want to distribute the negative 4. So we will get 18x minus 40 plus 12x is greater than, distribute the 5, we'll get 30x minus 40. So on the left-hand side, we have these like terms of 18 and 12x. So we'll get 30x minus 40 is greater than 30x minus 40. So we subtract the 30x from both sides, and you may have already noticed that those completely cancel. So that just leaves us with negative 40 is greater than negative 40. Notice this time we do not have greater than or equal to. It's a strict inequality. So negative 40 is not bigger than negative 40. So this is a false statement. This means that we have no solution. So, I mean, you probably won't be asked to graph, but if you are, it would just be an empty graph. You wouldn't shade anything. And no solution, you can denote it with a 0 with a line through it. That means the empty set. But probably just putting no solution would be fine. Okay, our last example, I want you to look over the work given by a student. It's not an actual student's work, it's something that I created. But the point is for you to get used to looking and evaluating at work and trying to find errors and decide what happened. So before I go through it, please pause the video, look through it and see if you can find one or more errors, highlight those errors, and then show how to actually correctly work the problem. So in the first step, if we weren't looking at the work, what we would do is distribute the negative on the left, and on the right we would be distributing the 3. So negative times x is negative x, and that's what they have here. And then negative times negative 2 is positive 2. Notice that here the work shows a negative 2. So here's the first error right here. That should be a positive 2. Okay, is greater than or equal to 3 times x is 3x, 3 times negative 1 is negative 3, and then they brought down the negative 8x. So far the only error that we've seen is that negative sign. So I'm going to go ahead and come over here and write the correct thing. So negative x plus 2 greater than or equal to 3x minus 3 minus 8x. Okay, so now we're going to evaluate from the second step, assuming that that was right. Let's see if they made any errors, bringing that down to the next step. So the next thing we should do is combine like terms. So if I'm combining like terms, and assuming this person made no errors, they would be able to combine 3x and a negative 8x. So they brought down the negative x minus 2. They brought down their inequality symbol. 3x minus 8x is negative 5x. And then they brought down the negative 3. So this next step looks good. They did not make errors based on what they had in the previous step. Okay, now from here, what should we do next? Next, we would be moving the x pieces over to the left. So we would add 5x to both sides, and we would be moving the constants to the right. So we would be adding 2 to both sides. Negative x plus 5x is 4x, so that's good. Negative 3 plus 2 is negative 1, so that is also good. So this step is good. Okay, so now let's check their work from step, or the fourth inequality to the fifth. So what should we do next? So next we should get the x by itself, so divide by 4. So we would get x. Did we divide by a negative? No, we did not. So should we have flipped the inequality symbol? No. So there's another error that this person made, is that they flipped the inequality symbol when they shouldn't. They got the correct fraction, negative 1/4, but they flipped the inequality, and they shouldn't have because we didn't divide by a negative. So that would be wrong too. So let's show the correct process. We did the first step. Now we will show combining like terms. Okay. So we would say negative x plus 2 is greater than or equal to negative 5x minus 3. We would add 5x to both sides, and we would subtract 2 from both sides. Now notice in this step they added 2, and that's because they had the wrong sign on that 2. So we will have 4x is greater than or equal to negative 5. And then in our case, we will need to divide by 4, and we'll get x is greater than or equal to negative 5/4. So if you're asked to identify the errors, we did. We showed the correct work to the side. You may also be asked to explain the errors, and if so, you could kind of label them. Error 1 was did not distribute the negative. And then error 2 was right here, and that was flipped an equality symbol. Unnecessarily. And I might be misspelling that. If I am, I apologize. But they flipped the inequality symbol when they did not need to, because we did not divide by a negative.